That's weird. The music from the radio is getting cut off by that armchair. I forgot to enable SweejTech propagation. 64 rays on the GPU and takes the size of the sound source into account. So plays nice with armchairs and walls. SweejTech propagation. Geometry aware, GPU based obstruction for UE5, compatible with native audio or any middleware. When enabled on a sound source, the native audio system in Unreal Engine handles obstruction with a single ray cast between the source and the listener. If the single ray hits something, your sound will get obstructed, regardless of the actual size of your sound source. This can be okay if there's a building between the source and the listener, but for other objects, for example this streetlight, it can be problematic. SweejTech propagation solves this issue by casting rays between a sphere around the sound source and a sphere around the listener. You can hear that now the obstruction caused by the building affects the sound in a more continuous way, and the thin pole of the streetlight barely obstructs the sound at all, as one would expect in the real world. We'll just lock the listener position for a moment to take a closer look. What you can see here is the source sphere, or rather the hemisphere of the source that's facing the listener, and the number of sound positions on that hemisphere. Now we can see the listener sphere and its corresponding positions, and the rays that are being cast on the GPU between them. The system traces rays between these corresponding positions on the source and listener, and the ratio of hits to misses gives us a value between 0 and 1, 0 being fully open and 1 being fully obstructed. Looking a little closer, we can see that the positions are actually divided into two types. The outer edge of the hemisphere, shown as blue-green or teal colour when unobstructed and purple when obstructed, and the inner positions, shown as green when unobstructed and red when obstructed. The resulting inner and outer obstruction values are shown in the obstruction inspector, and a resulting raw obstruction value takes the lowest of these, so the least obstructed path wins. This gives us a more natural result for the kind of thin obstruction scenarios such as the lamppost, or when sources propagate out from between two pieces of geometry. All of this is very customizable to suit your project's needs. For example, in the project settings, you have control over how the points on the source hemisphere are distributed. Here you have a choice between uniform distribution or cosine distribution, and the points spread factor lets you bias the points towards the center or the rim of the source hemisphere. Here you can also set the listener radius. The default is 100 units, but larger values will mean that there needs to be more geometry between the listener and the source for it to become fully obstructed, and smaller values will make the obstruction effects more sensitive to geometry. With the plugin enabled, the Swede Propagation toolbar is where you control how each sound asset will respond to the obstruction value. It defaults to the settings in the default Swede Propagation sound definition asset, but you can override these locally for each sound. Or you can create your own propagation sound definition assets to share settings between similar sounds, as we'll see in a minute. The frequency at max obstruction is the filter frequency applied when the sound is fully obstructed, and attenuation at max obstruction is the attenuation applied to the sound when it's fully obstructed. Source radius sets the size of the sphere around your sound, which will have a big impact on the ratio of successful or blocked rays, and hence the obstruction value. Obstruction scaling mode lets you define exactly how the filter and attenuation respond to the resulting obstruction values. For example, here we might want the grenade explosion sound to be unaffected by the smaller rocks. With the default setting, the full range of the resulting obstruction value is used, but we can override this to only apply the obstruction effects over the range of, for example, 0.3 to 1. So values less than 0.3 will no longer result in any obstruction effect. Instead, the 0 to 1 output of the obstruction system is scaled across the 0.3 to 1 range. In addition to using linear numeric values, you can also use bespoke curves in order to achieve exactly the effect that you want. The obstruction value smoothing time determines how fast the system transitions between obstruction states. And again, you can determine this on a per asset basis. For example, in the case of this relatively fast moving aircraft, I might override the default value of 100 milliseconds and instead choose 50 milliseconds so that we can hear the obstruction filter and attenuation adapt more quickly as the sound propagates around the buildings in the scene. In your project, you will very likely have groups of sounds that you want to respond in the same way to obstruction. By using Swede's propagation sound definition assets, you can share settings across different groups of sounds. Just change the settings within the shared propagation sound definition, and every sound using it updates instantly. And of course, you can override these settings locally to make exceptions for specific sounds. Let's look at a potential issue and the SweejTech solution to it. When a sound source is close to geometry, part of its obstruction sound sphere can bleed through floors or walls, meaning that some rays register as obstructed, even when there's no obstruction between the source and the listener. The SweejTech solution to this is the aptly named Squishy Sound Sphere. When enabled in the project settings, each sound's obstruction sound sphere deforms to take the surrounding geometry into account. Here you can watch it happening live in the debug view. Note how this time the resulting obstruction on the tank remains minimal, only rising to a maximum of 0.2 when there's actual obstruction occurring between the sound sphere and the listener sphere. There will be instances where you want to exclude specific meshes or specific geometry on a mesh for obstruction purposes. Let's take this tree as an example. At the moment, it's obstructing any sound that has Swede propagation enabled. We can stop it obstructing sounds by adding Swede propagation mesh asset user data to the mesh actor. By default, this has ignore mesh enabled, so the whole mesh will be ignored in terms of obstruction. To take this a step further, you might want to exclude specific geometry on a mesh. For example, you may want the trunk and branches of the tree to obstruct sounds, but not the leaves. To do this, we can uncheck the Ignore Mesh option and select the specific segments to ignore. In the viewport, using the Ray Tracing Debug Picker, you can find the segment index. So here we can see that the segment index of the trunk is 1 and the segment index of the leaves is 0. With 0 defined in the ignored segments index, we can see that the trunk of the tree obstructs the sound, but the leaves do not. If we wanted this to apply to all tree meshes of this type rather than specific instances, we could add the Swede propagation mesh asset user data to the static mesh itself. And for assets generated at runtime, you can do all of this within their blueprint. So that's a quick overview of SweejTech Propagation, a new GPU-based propagation plugin for Unreal Engine 5 that's also compatible with middleware. For an evaluation copy or to chat more about the needs of your project, just reach out to us at SweejTech or join our Discord.